Hi, good morning. Okay, now we're going to talk about the momentum. Okay, this time. Okay, what exactly is a momentum? So I'll give you an example. So if I'm sitting here, I'm standing there. Okay, now there are three other objects. Okay, a basketball, a, a car, okay, and a truck. Okay, that's a truck. Now, say all these three objects, okay, are traveled at 2 meters per second towards me. Okay, now when those when those objects collide with me, they doing they're going to do different damages. Okay, for instance, if I hit by a basketball, I mean I will be okay. I will be normal. If I be hit by a car, perhaps I get injured. Okay, now if I hit by a truck, now I don't want to do that, but it would be more damage down to me. Okay. However, out of this, okay, now they all travel. Those three objects, they all traveled at the same speed. Okay. Now, when they hit me, they do different damage. Okay. So the difference of them are the masses. Okay. A basketball is light. Okay. Now a car is heavy. A truck is really really heavy. Now, how do we measure this in physics? Okay. So we use momentum. Okay. Momentum is has a simple p measured in mass times velocity. Okay. Now we can to understand it simply, to understand momentum simply, just remember it measures the compact effect, okay, during a collision. Okay. So it's mass times velocity. Okay. The mass, well, the unit of momentum, okay, we can figure it out from the equation. Okay. Mass has a mass has a unit of kilograms. Okay, velocity is in meters per second. Okay, so the unit for momentum will be kilogram meters per second because they times each other. So kilogram times meters per second. Okay, so this is your the unit for momentum. Okay, now let's do an example about this. Okay, so we have a car. Okay, this mass moving at this speed. What is the momentum? Now, in the exam, when doing this question, always remember write down the equation. Okay. Now, if you write down the equation, you get 1 mark. Okay, you write down the equation without doing anything else, you get 1 mark. Then let's try to work on. Then just put down the number in. Okay, times 20, which is the unit kilogram per meter, kilogram meter per second. Okay, kilogram meter second. They times each other, so that's your answer. Okay, now we're going to talk about impulse. Okay, so impulse is similar to momentum. Okay, so it's measured in impulse I is measured in force times delta t. Okay, now I show you what it means. Okay. Well, let's find out the unit first. Okay, the unit of impulse will be newtons second, okay, because the unit of force is newtons, the unit of time will be seconds. Okay, so impulse has a unit of newton seconds. Now, the idea was, okay, during a collision or an impact, okay, say something, say I have a, say there's a ball, a basketball, okay, impact on the wall. Then it bounces back. Okay, so what happened here was impulse measures. Okay, impulse measures well, the effect of the impulse basically in this case. Okay, to make it simple, okay, impulse measures the effect of the ball, okay, of the marble, okay, on the wall. Okay. Or on the other hand, we can say impulse measures the effect of the wall on the ball. Okay. How do we measure it? Is in newtons second. Okay. Now what we can say is, okay, the time here, okay, practically we can call it a contact time. Okay. Just to make it simple to understand. So the time in seconds that the ball actually in contact with the wall. Okay, now, yep. Okay, now let's do a question to make this. Let's do a simple question first. Okay, now, so a bat exerts a force of this much, solves for time of 5 milliseconds on a ball. What is impulse? Okay, so the impulse is force times the contact time. The contact time will be 5 milliseconds, and the force will be 2.1 times 10 power 3 newtons. Okay, now again in the exam, write down equation, then we put in the value. Okay, so it's going to be 10.5 newtons second if you do it in your calculator. So as we can say, okay, the bat only in contact with the ball, okay, for 5 milliseconds. So this is the impulse. Okay, so that's a force. Yep. Okay, so impulse, that's what we call it an impulse, the effect on the ball by the bat. Okay, is this much. It is a similar. I'll show you what's happened next. Now, what can we say about impulse and the momentum is they are similar. So let me just do this. Okay, so momentum has a unit of kilogram meter per second. Okay, so impulse has a unit of newtons second. Okay, not per second, newton second. Okay, so what does this mean? Okay, they are practically similar. These two, well, we can say they're the same, but use the word similar. Okay, they are similar. Okay, I look at the unit. I show you why. Okay, if you look at the unit of impulse closely, it's newtons per second. Newtons second. Okay, now, a newton, okay, 1 newton. Sorry, let's look at where Newton came from. Newton is force ma. Okay, 1 Newton, the unit of Newton is basically equivalent to kilogram, the unit of mass, meters per second square. Okay, so what we can do is we put this in. Okay, we substitute this. 1 Newton is the same as 1 kilogram meters per square second. Per second square. Right? We substitute the unit of Newton into impulse. The unit of impulse. I would have kilogram meters per second square times a second. That's the unit of impulse. So basic mass. Okay, the second cancels out. We can write it down as this, okay, which is similar to kilogram meters per second. These two are basically the same, okay, because these two units are the same, so they means the same thing. Okay. The only difference is if you go back. If you go back to impulse, now the time is a contact time. Okay, it's a contact time. It's a delta t change in time. Okay, so you found it in most of books. What it says is, okay, now in most of book, what it says, the change in momentum equals to impulse. Okay, so this is the equation we're going to always use. So just summarize it, okay, which is force times delta t, okay, change in momentum, so mass 1, well, we do it in detail. I show you. It's perhaps more useful for me to show you a question. Now, let's go on to this there. Okay, have a read at this question. Okay. A van of this much travels at this speed, so I name it M1. Okay. So wave 1 collide head-on with the power pole. Okay. So the power pole has a velocity of 0. the impact crashes by 6 meters, bringing the 1 to the rest. So the 1 to the rest. So um, after the crash, there will be V2. V2 will be 0. Now take the average force. Now the average force the pole exert on the 1 is this. Find the time for the impact. Okay. Now in this question, you need to both. It's a collision. Okay. Now recommended is a collision. It's a question contains collision. So there must you have to use momentum and impulse. Okay. Now what we know is the impulse is the change of momentum. So let's find the change of momentum on the pole. Sorry, of the van first. Okay. Now before, so in order to find the change will be the momentum after take away the momentum before. Okay, to do this, momentum after we only find the 1, so will be momentum after will be mass times v2. Okay, the final velocity. Take away mass times v1, the initial velocity. So I have 20 times 0, take away 20, sorry, not 20, so what we have is 1,200 kilogram times 0, take away 1,200 kilogram times 20. So it will be minus 24,000 newtons second, or kilogram meter per second. Okay, this is the impulse. So we also know impulse will be force times the contact time. Okay, now just remember the change in what we're finding here is the change of momentum of the van. Okay, now we have a minus sign. What it means? Okay, the one had an impact. Okay, the momentum losses has an impact on the pole, on the power pole. Okay, so what we try to find is the time of the impact. So the average force that the pole exert on the van, where we have pole exert on the one is positive here. So what we can do is, now when we're talking about the impulse, we're talking about the force. Okay, the impulse here is the impulse of pole. Okay, basically the effect of the power pole on the van. Okay, so we can get rid of the minus sign. Okay, 1, the effect of 1 on the pole. Okay, here, impulse of the pole on the 1, so we get rid of the minus. Okay, force times delta t. So your contact time will be this. Put it in calculator. Will be 0.0 sorry, should be 0.6 second. Okay, that's it. So in this equation, you need to find the impulse by calculating the change in momentum. Then use the impulse to find the impact time. Okay,